All right, so we're going to start off by measuring 1 gram of silica gel into an Erlenmeyer flask so that we can create our slurry for our column chromatography. I already have pre-tiered my 50 milliliter Erlenmeyer flask. I'm going to go ahead and measure 1 gram. Okay, so we've got 1.01 grams of silica in our 50 milliliter Erlenmeyer flask. We're going to go ahead and go make a slurry. Okay, so with our 1 gram of silica in our Erlenmeyer flask, we're going to create a slurry by adding enough hexanes to basically make the entire silica gel here wet. Okay, so it'll look like it's turning clear as I add hexanes to the silica gel here. Well, it's currently not gel, but it is a solid. And once we add the liquid to it, then it technically becomes a gel-like. All right, let me close my container of hexanes here, and I'm going to give it a swirl. And if you notice, now the silica appears somewhat clear inside of the Erlenmeyer flask here. And now I will be able to begin creating my column for column chromatography. Since hexanes evaporates extremely quickly, I'm going to go ahead and stopper my solution, and we're going to begin with the column building. For the column here, we have a glass pipette, and we have attached a small piece of cotton down at the bottom, along with some plastic tubing. And here we have a clamp that's just basically going to act kind of like a stopcock for us. So this is going to be somewhat like a burette, but we're going to have to fill this with the silica gel. I'm going to start by adding a little bit of the hexanes through the bottom here, just to make sure that we get all of the air out of the cotton ball there. So I'm going to place my hexane solution underneath, just because since this is hexanes and what we're going to be pouring through is hexanes, I'll be able to combine the two solutions. So let me add just a bit, about 0.5 milliliter. And now I'm going to open the clamp down below to allow that liquid to come out. And again, the reason why I'm doing this is to ensure that we get any air bubbles out of that cotton ball. Okay, let me go ahead and reclamp this. And notice I did get a little bit of liquid that kind of got pressurized back up. Okay, next I'm going to add some sand. So this is sand, sea-washed sand. However, it's extremely fine grained. So this is kind of like the really, really tiny sand grains that you would find at the beach. And it's also been purified. There's no other compounds in here besides sand. I'm going to go ahead and add a small amount of sand here to create a barrier. Right, just a small amount of sand. And it will get stuck on the inside of the tube because it is wet in there from the hexanes. So what I can do is add a little more hexanes to help wash the sand down, and then just collect it in my Erlenmeyer flask. There we go. Okay. Okay, now I'm going to make my sand layer somewhat even by giving it a slight tap with my microspatula. And now I can let out that amount of liquid that we had added. Okay, I'm actually going to stop right above the sand barrier there. And if you notice, again, a little bit of liquid got pushed up by, the pressure at the bottom. So right now my sand looks somewhat wet there, and we are good to go. Okay, so I have a pipette here, a plastic pipette where the end has been cut off. So I'm going to go ahead and use my glove here so you guys can see that we've cut it at somewhat of an angle. And what this is going to do for us is help us collect the slurry with plenty of the silica in it. We want liquid plus silica into our tube here. So let's go ahead and start adding the slurry. And I'm going to do my best to slurp up as much as I can with both liquid and solid here. So what you should see inside the tube is that we're kind of creating a layer down below that is on top of the sand. Okay, I'm going to go ahead and try one more portion here. And I'm going to pause and let out some of my liquid. Before I do that, I'm going to give it a slight tap with my micro spatula here just to ensure that the layers of silica are nice and even and that we're not incorporating any air. Okay, I'm going to go ahead and open this stopcock here. Now, what's very important when you're building a column is that now that you've added silica, it must stay moist at all times. So I'm actually going to pause the liquid a few millimeters above the silica here so that I can ensure that it stays moist. Okay, so I will keep going and creating my silica column with the gel until we get pretty close to the top of this pipette. I'm going to let out my liquid. The liquid I am working with currently is pure hexanes. And we're doing this with pure hexanes because hexanes is the less polar solvent that we will be using for the separation today. Okay, with these column chromatography situations, the least polar solvent is always used first. Okay, and this should be the last portion of silica I need to add, but we'll see. Never know until the column is built. I think that's all we're going to get out of the silica here. So at this point, since we have added as much silica as we can from the slurry, we will go ahead and create our upper sand barrier. Now for this upper sand barrier, I need to ensure that I leave plenty of liquid above the silica column here. So the silica is about here where the prong of the of the ring stand holder is at. And so at this point, I will add a little more sand, and I have plenty of liquid above that silica at the moment. Now it's important to do this because sand is pretty dense in comparison to silica. Yes, silica is made out of sand, but sand has other components in there as well, and so it's pretty dense, and so you want it to gently get that top layer. Okay, and we also want this top layer to be somewhat thick, so we want about a 2 to 3 millimeter minimum there, and hopefully somewhat even. I'm going to go ahead and give it one more small portion of sand. There we go. Okay, that looks good. All right, so our column is built. All right, now we'll be able to load our oil onto the column. But before we do that, let me ensure that our liquid lines are level to each other. So I'm making sure that the hexanes on the inside, that meniscus is right about level with the sand barrier. There we go. Okay, so the sand barrier appears slightly dry at the top, but what I have made sure is that meniscus of hexanes is actually right at that little bit of sand bottom. Now we can load my oil. So for this portion, I guess we'll do caraway oil first. Let's go ahead and take a look at our caraway oil. Caraway oil is a nice, kind of slightly yellow oil. It looks a little bit like cooking oil. And when you open your caraway oil, you'll definitely know that you are opening caraway. It has a nice sweet smell to it, but after a few seconds, your nose kind of has a pinch to it. So it's a little bit of a sweet but gross smell at the same time. All right, so let me go ahead and get my micropipette ready. Okay, so that last little droplet did kind of touch the side, and that's totally fine. Okay, let me just close the jar of caraway oil because it is a very potent smell. Now, in this next piece, I am loading the column. I'm finishing the loading of the column by ensuring that that little bit of oil drops down into that sand barrier. Okay, this is very important because if you don't allow this to drop into the sand barrier, you will not get proper separation of the compounds. Okay, so if you notice, again, the sand looks somewhat dry, but I have ensured that the meniscus of the oil is now going to be towards the bottom of the sand. All right, and you can actually start to see that upper layer right next to the sand turn a somewhat oily clear color. All right, that oily clear color indicates that the oil is fully loading onto the top of the silica. Okay. Now, we will begin the separation, but before I begin the separation, I will do some pre-measuring of liquid. I'm going to pre-measure 2 milliliters of hexanes into 3 vials. So, we have 3 vials set up here, and they are, numbered 1, 2, 3, 4, and 5. So, in my first 3 vials here, I will measure 2 milliliters of hexanes. And again, we're going to add hexanes first to our microcolumn because we always add the less polar solvent first. That's okay. Okay. For our last 2 portions of solution, we're actually going to switch solutions. So in this case, for our last 2 solutions, we will increase the polarity of our solvent by using a 10% solution of acetone dissolved into hexanes. This means that in this solution, at any given time, you will have 10% of this liquid here be acetone. The other 90% will be hexanes. Okay, so that little bit of acetone greatly increases the polarity of the solution because acetone, being a ketone, is much more polar. Okay. Now that I have my solutions ready to go, we will be able to start our separation.